Hello everybody, Professor Zinilovic here. In this video we're going to discuss Python tuples and Python sets. Let's get started. Let's see what is a Python tuple. A tuple is very similar to a list. However, it is immutable. Okay, once you create a tuple, you can't add additional elements to tuple. Existing elements cannot be removed. You can't add, you can't remove elements from the tuple, and values that are already stored in tuple elements, they can be changed. This is the syntax. This is the variable name, assignment operator, followed by open parentheses, and then items, item 1, 2, 3, item n, and then closed parentheses. Okay, that is the syntax. Let's see that in an example. Okay, I have some ready-made code, and let me just make it a little bit bigger. It is easier to see. As I mentioned, this is the syntax. We're going to put here syntax. We know what it is, and it is generically something like that. Now, to create a tuple, let's say here I want to create a tuple that contains numbers 1, 2, 3, and 4, and I want to call it data. If I want to access an element, let's say in position 2, this is position 0, position 1, position 2, position 3. It's a 0-based index, right? Just like with lists. And if I want to access element in position 2, and display its contents. That's what I want to do. And this should output number 3. This should output value 3. Then I could print only particular, like here if I have A, B, C, and D, and I want to assign data to it, my data contains 1, 2, 3, and 4, which is tuple. And I want to assign that to variables A, B, C, and D. Then from data, from tuple, whatever is in position 0 is going to be assigned to the first variable, in this case variable A. Whatever is in position 2, in this case position 1, sorry, position 0, position 1 is going to be assigned to B. Position 2 is going to be assigned to C, and so forth. Now I want to print A, B, just to see what I got, and I got 1 and 2. And then other thing that I can check, there's a way to check whether a particular value is in tuple, and this returns true or false. In this case, we're checking whether 3 is in data, and we can try another one. This one will return true if I do print, and let's say 14. In data, this should return, the output should be false. Okay, let's run it. Let's see what this does. And we got 3, which is our value in position 2. That's correct. Then here we assigned data, from tuple, we assigned it to variables A, B, C, and D. We're printing A and B. We get 1 and 2. Here we check whether 3 is a member of the tuple. It tells us that it is. 14 is not a member of tuple. That's why it returns false. And we can check one more. Let me comment this out. It doesn't appear in the printout. Oops, I didn't mean to do that. I meant to comment it out. And here we want to check, or actually not check, but we want to display. Let's display contents of B and C. Okay. Print, and here I'm gonna specify it C, and we're gonna say what's in C. Like we're gonna say that it's a digit, and we're gonna go to the new line. And we're going to say that in D we have another digit, like that. And we're going to use the format function. Next. and here we're going to put C and D. That should take care of it. Now I need to uncomment this one. That's why it is not recognizing what it is. That's why it was underlying it. We did unpacking, and now we're going to display that. C is 3, D is 4, and if you look at the data, 3 and 4. Okay, that's a little bit about tuples. Moving forward, this is what we just did, and we verified the output here in our PyCharm. Let's move forward and see what methods are available in tuples. Tuples support many list operations. They support subscript indexing. There's some built-in methods such as length, minimum, maximum. And then these are, because this is immutable, these methods are not supported in tuples. You cannot append, remove, insert, reverse, or sort. Okay, let's have a look at another interesting scenario. We know that tuples are immutable, but that doesn't prevent you from storing mutable objects in a tuple. Here I have my tuple, and I have different data types. I have 2 integers, 10 and 20. Then I have a string, which is Miami-Dade College, and then I have a list consisting of integers 5, -8, 20, and 13. And this is what this would look like if we could peek into computer memory to see how this is allocated. This is our variable. It is pointing to a tuple in memory, and then inside of tuple, each member of the tuple points to an integer, the first one. The second one points to the second integer, and the third one, sorry, I went a little one extra. In computer memory, here's your variable my tuple. This is memory location that is allocated for this tuple, and as you see, members of tuple are basically pointers to, in this case, an integer, second integer, a string, and then a list. We can change. This is a mutable object. String is a not mutable object, but list is, and we could change our list. For example, if I want to add additional element to my list, I can say my tuple, then in position 3, because I want to access the list, position 0, position 1 points to integer, position 2 points to the string that we have, and then position 3 points to my list. Here I want to append Miami Heat, and it's going to do that. And if we print my tuple, it is going to display 1020 Miami-Dade College, then our list with Miami Heat. Okay, let's try this and see what this does. Let's go back here. I'm going to comment all this out. It doesn't interfere with demonstration. And here we're going to say that this is, I'm going to call this demo mutable objects in a tuple. All right, let me paste this code. This is the original tuple that we have. It prints 1020 Miami-Dade College, and that is just fine. Now we want to add to this tuple. We're going to say my tuple, and then we want in position 3, because that's where our list is. Then we want to append. And what do I want to append? I believe we said we want to append Miami Heat. And now we want to print this again to demonstrate that this works. And if I compile and run that, now my tuple is richer for additional element in the list that is a member of this tuple. Okay, that's how that works. You, by default, whatever you create, when you create a tuple, whatever you create is immutable, right? However, you can store mutable objects in tuple. In this case, we have a list, which is a mutable object, and that object, if you can access it through the index, you can then modify its contents. You can append and so forth. Okay, now immutable objects, they can be changed. Okay, I want to go and change the value in position 0, which is what I have there for it's my integer, and I don't have any assigned value to it. If I go back here, let me comment this out. I'm gonna comment this out, and this is another demo. This is immutable objects cannot be changed. And let's see why. Here I have, in first position, I have value 10. I would like to make it 20. All right, now this doesn't belong, this is part of the tuple. It doesn't have mutable object associated with it. If I try to compile this, I'm gonna get an error. I get an error, and that's why you get an error. If we go back to this slide, if you see here, this is not associated with any variable. If you have, for example, if you have a regular integer, something like this, and you try, let's say my value is 10, and you print that, so print my value, you see the contents of that, that's going to tell us that it's 10. And now I can go here and say that my value is 15 or 14, doesn't matter, and then I want to print my value, and this should be my value, and this will give me now that this is 14. Why? Because I have a variable associated with it, and its data type is an integer. Here I have a pointer to an integer literal. And because this is a tuple, which is immutable data type, we're unable to do it. If I comment this out and uncomment this guy, this is the reason why we can't do it. And as you see, the IDE is signaling to me that this is an invalid assignment. And if I try to run it, obviously it says attempt to assign 11, some new value, to the first position in my tuple. And then it says tuple object does not support item assignment. Okay, hopefully that is clear. Let's have a look at why should we use tuples. When you look at it, it's pretty restrictive. And now the natural question is, why should we use a tuple versus a list? For one thing, tuples are faster than lists. They're safer because you can't add elements and remove elements like you can with a list. And once you create a tuple, its elements will always point to the same object. Now, having said all that, there are functions that will allow you to convert from a list to tuple and from tuple to a list. Okay, this following demo showcases that. Let's go here, let's comment this out like so, and we're gonna have a new demo. This demo is converting from list to tuple and vice versa. Okay, let's see how we can do that. Here's the example code. I have a tuple. I want to convert it to a list. I pass my tuple to this function called list, and it's going to convert it, and now I have a list. Data type of, basically what I'm printing here is the data type of my tuple, and I'm printing data type of my list, and I display what tuple is, and I display what the list is. Let's see what that is. As you see, the data types are correct, and here's tuple, rigid, you can't do many things with it, and we've converted it to a list. Similarly, you can take a list, convert it to a tuple. All right, this brings me to Python sets. Before we get into Python sets, we need to understand the set theory. And I'm pretty sure that everybody has at some point encountered sets in your math education. And as you know, set theory is a branch of math that studies sets, which are basically collections of objects. You have a relationship between an object and a set. An object is a member, or we also say element, of a set. Okay, and basically set is a collection of objects that have something in common, or they follow some kind of rule. In math, set notation is these curly braces, and you separate them by comma. Here I have a set A, and then I have, well, this is an assignment operator in computer science, but in math that's equal, then curly brace, coat, comma, hat, scarf, and so forth, and I denote the ending of that set with a closing curly brace. Here it's more descriptive. Set name, finger, and then I have thumb, index, middle, ring, and little finger. Okay, that's set theory. Now in Python, set is an object that stores a collection of data. It's a mutable object, and it resembles math sets such as that all members must be unique. Set members can be of different data type, and they are unordered. There's no order in your sets. All right, let's have a look how we can create an empty set. This is how you do it. You have a variable, mySet, and then an assignment operator, and then set, and then open and closed parentheses. That will create an empty set. You want to add elements to your set, you can use the add method. mySet, then dot to invoke the method add, and then in parentheses whatever the element you are adding. Let's have a look at it in IDE, how that works. Here it is. Let me just pull up the IDE. I'm going to comment this out. I don't want this. So let's comment this out, and let's have a demo. Intro to Python sets. Okay, and let me paste that. This statement here will create an empty set, and then here we're going to add 10, blueberry, 398, apple, and 9, and then we're going to print the set. We're going to print my set. 10 is an integer, this is a string, this is a floating point number, this is a string, and then we have an integer again. Let's go ahead and run that, and as you see, this is unordered. I've added 10, blueberry, 398, apple, 9, and my set. It's printing 398, blueberry, then apple, then 9, and then 10. Okay, it just, that's how it works. Okay, so when you try to add another thing, when you try to add an element to a set that's already a member of that set, the add method will be silent. It's not going to raise any exception. Let's try to add something that exists. In my set I have 10 or 9 or blueberry. Let's do my set, and then I add, and we're gonna try to add 10. 10 already exists, and see, there's no, it's silent. Oops, let's try it one more time, and when I run it, it is not going to raise an exception. See, I'm running it and it's just silent. We have to be cognizant of that. All right, now there's a way for you to create a non-empty set. Okay, it's pretty straightforward. You can do you can use the set method, and then you can put, for example, a list. Like, you can also, there's a short hand to do this, and I'm going to demonstrate both. Let's have a quick look at how this works. Let me comment this out. Oops, I don't want debug. Let me just go here real quick, and let's comment this out. And oops, I don't want to delete it because I do intend to share this code. And this is going to be demo, and this is non-empty set. Okay, this is one way to do it. And I'm going to comment this out just for a second because we don't need that code yet. If I compile and run this, it gives me my sets that I put. And again, see, it gives me in a different order than I put it. Now this, as you see, the IDE is complaining. You know, it's just a warning that there's nothing wrong with this, but there's a little bit easier way for you to do this. I'm going to comment this code out and show you an easier way. When you're dealing with a list, then you can do this curly brace just like in math, and right there you have your set. Here it is displayed like when you invoke print, it is displayed in on your screen. Okay, now let's uncomment this. In this example here, I am adding a string Miami-Dade College. Okay, now this is a string. Now one thing that let me put here that this is a string, and one thing that you need to remember is that that the sets, elements in a set are unique. A string is a collection of characters, and when you try to print this, as you see here, you have capital M, then you have lowercase m, you have I, then another I, then you have E, and E, only one I is going to be allowed in this set, only one E, only one A, not two A's, and so forth. Okay, execute this and you see that we get only the unique characters. Okay, that is how that works. Please keep that in mind, that elements in a set are unique, and that's why you're not going to see repetition. You're not going to see certain elements repeated in a set. Okay, now another way for you to create a set, I already demonstrated that, would be using the curly braces and comma in between. This is the preferred method to create your set, and here I went one step further where I am displaying what is the data type, so you're sure that this is not something else. If I go back here and see how we created that set with the curly braces, now I'm gonna put this as well to show what is the data type of that set, and then I'm just gonna comment these out. We're not confused with the output. See, the data type is set and the values are whatever values we put in there. All right, that is a preferred method to create a non-empty set. And then here you have a couple of examples. This is a list here. You have a Miami-Dade, Miami, one word, Dade, and then college. And it's going to say that the data type is set and the values are, this is going to be a list of strings. Versus when you do it this way, this is one string, then it takes characters. It takes characters that are, and then just uses unique characters for that set. Okay, and the last one, the last one here, when I do a set like this, that's the one that does the, okay, here we have a string literal and it treats it as one string. Okay, it doesn't treat it as string of characters. However, when you do it with a set method and you pass to it a string, you see how different this is. This one here is with the curly braces and it's expecting you to give it some kind of list or something like that, right? But this, in this case, this list has only one member, and in this case it's just going to display the first one. It's going to say that this is Miami-Dade College. Here this list has 3 members, has 3 strings. Here it has 1 string. There's no, like in this example, when you use the constructor, when you use this method set and you pass a string to it, then it's going to treat each character as a member or element of that set, and it's going to only use unique characters. Okay, please keep that in mind. That is very important when you're creating your sets. The methods you have seen: add method, which adds an element to a set, but we also have an update, remove or discard. These are 2 different methods and they differ slightly. And then we have clear. Okay, let's have a look at that. All right, I want to introduce the update method to you. And in this example here, we have a set that has 10, 20, and 30. Okay, and it's gonna output that as 10, 20, 30. Then I want to update my set with following values: 40, 50, and 60. Okay, now this is a list. You see, this is a list inside that was passed to this method. 40, 50, and 60 will be added to the previous list. Okay, let's have a quick look at that. Here's that example. Let's go here, and this is the update method. Let me just comment this out. This demo is demo the update method. Okay, and let's paste it here. This is my set. Now notice I put set. I purposely did that. And then here I am passing a list to the update method to update my list. If I run this, initial one is going to give me 10, 20, 30 like I wanted, and then here gives me additional list that I added to that. Now obviously you could have done this with shorthand with a different method. You could have said something like this: this is 10, 20, and 30. And if you run the result, the end result is the same. Okay, so let's have a look at it in another example. Here I have set 1 and I set it to 10, 20, 30. Then I print it. Then I declare set 2 and I declare this set to be 40, 50, 60. Then I pass set 2 to the update method. I pass it here, and then it shows you what was the end result after that. Pretty much the same thing. Okay, let's demonstrate that real quick. This is still the same demo. I'm just gonna comment this out and paste this in it. Here I have set. In this case, you're passing an actual set variable to this method called update. Now I'm going to make it a more modern here, like so, and I can leave the other one this way. It doesn't really matter. When you compile and run this, you're going to end up with the same thing. But the key thing that I want you to take away from this demonstration: set 1 is a variable, and then set 2 is also a variable. And to update, in the previous example, we passed the actual list. Okay, here we're passing variable that has contents of that list. Okay, and then we just display that down here. All right, now I have one more example here to share with you real quick. Let me comment this out and let me show you. Oops, I didn't mean to delete that. Let me show you this one. Here I have set 10, 20, 30, 40. Before the update is that. Now here I'm adding ABCD. What is it going to display? ABCD is what? It's a string literal. Okay, how is the update going to take this ABCD? Is it going to take it as one string ABCD, or is it going to take it as one character to be a member of the new set? Okay, let's have a look at it. And you see this. Do I have an error? Just 1 second, let me see, do I have an error? Yes, I have an error. I have that, I forgot that. Let's try one more time. It does, because it basically works the same way as the add method. When you give it a string, like string literal, then it breaks it down into characters, and this is now our new set. All right, moving forward, let's have a look at remove and discard. They both remove the specified item from the set, and all you have to do is pass the item to be removed from the set as an argument to either one of these methods. Now there's two, they react slightly differently. The remove method is going to raise key error exception if what you passed it as an argument to be removed from the set doesn't exist in the set. The discard method will not raise an exception. Remove is a little more safe, a little safer, because if you're trying to remove something that doesn't exist in a set, then it will raise an exception, and then you can react to that exception. We haven't covered exceptions yet. Once we cover exceptions, then you're gonna know what to do at that point. All right, let's have a quick look at that. We're gonna demonstrate the remove method. Let me comment this out, and this is gonna be another demo. This is the remove method. Okay, here it is. Here's my set. I'm gonna change it slightly to make it more modern and or preferred method. Here we assign 10, 20, 30, 40, 50 to my set, and we display it, and then I want to remove 30. I want to remove 30, and then I want to print my set to verify that it indeed removed. Here it is. My set was 50, 20, 40, 10, 20, 30, 40, 50. I have removed 30 from it. Here's 50, 20, 40, 10, 30 is gone. Okay, now I'm gonna try to remove a non-existing element. We're gonna do that. And in this case, I'm removing 60, or I can try to remove 30, doesn't matter. Let's say 30 because we removed it, and if I run it now, it's gonna raise an exception. Okay, it's trying to remove non-existing element. Okay, this is safe, this is safer. Now let's comment this out, and let's try to use the discard method. The discard method is not going to report anything back. Here I'm trying to remove 30 from it, and when I run, it doesn't say anything. See, it's silent. You have a choice, you can use either one, but the remove method is safer because you can react in case there's an exception. Okay, this is what we just did programmatically. You can review that, and here's the discard method. Here we're discarding 30, and we are removing existing elements. Here we had 10, 20, 30, 40, 50, and it removed it. Then we're trying to remove non-existing elements. Here we're removing 60 or 30, doesn't matter, and as you see, there's no output, it's silent. Okay. Last method that we want to look at is the clear method. The clear method will remove all elements in a set. Here's an example of that. Let's take a quick look. I'm gonna comment this out like so, and we're gonna demonstrate demo. This is the clear method. Okay, I have a set that's 10, 20, 30, 10, just 3 elements. I'm going to display it, then I'm going to clear it, then I'm going to display to see what happened to my set. If I compile and execute this, my set is 10, 20, and 30. After the clear, I have nothing. I have an empty set. Okay. These are methods that are part of this of the set object. Now, you have a couple other things that you can do. there's a len function that's going to tell you how many elements are in your set. This can be particularly useful if you want to programmatically loop through your set. We haven't covered loops yet. Once we cover that, then you can use the length function to determine how many elements are in your set, and you can then loop through them. This demo is of the length function. This is not part of it. This function is not a member of the set object. This is just a function, and it's straightforward. I have a Florida cities, or my cities here, Miami, Orlando, Jacksonville, Tampa, and so forth. I print them. Then I decide to find out how many cities are in my set. Okay, that's accomplished with the len function, which takes a set as an argument. Okay, let's run that. And the major cities in Florida are 1, 2, 3, 4, 5, and there are 5 cities in the set. Okay, pretty straightforward. Now there's a couple other things that you can perform on sets. In math, let's do a quick refresher. There's something called an intersection of two sets. Here we have two sets P and Q. P has 1, 3, and 4 as members. Q has 2, 3, 4, 5, and 6 as members. And the relationship here, the question is, what is the relationship between these two sets? They share some data. They share 3 is shared, see? 4 is shared. 3 and 4 are members in both P and in Q. When you have something like that, that's called an intersection. Okay, we have another example here. I've set X and Y. X has 1, 2, 3. Y has 3, 4, and 5. And then this is a math symbol for intersection. It looks like upside down U. X intersection Y is 3. 3 is the only element in both sets that has membership in both sets. All right, that's a math refresher. Now here is a challenge. Try doing this before you move to the next slide. We here have 3, 6, 9, 12, 15, 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. What would be the intersection of P and Q? If you look at it, does 2 appear here? No. Does 4 appear here? No. Does 6 appear here? Yes. 6 and 6 right there. 8, no. Then do we have 10? No. 12 is in P and also in Q. 14 is not. 16 is not, and 18 is not. Okay, that would be the intersection of P and Q. Okay. In Python, an intersection is when you do an intersection, you get a result set back. You get a third set, so you have set A, set B. Then intersection is set C, that contains only the elements that appear in both sets. Okay, this is the syntax. You have a set, let's say set 1, then you access through the dot operator member method called intersection, to which you pass set 2. Alternative or shorthand syntax is set 1 ampersand set 2. And both of these techniques will return a new set. Okay, here's an example. I have set the one that we looked at a moment ago, and we're going to do an intersection. Let's demonstrate that. Here's an intersection of two sets. Just like in math, you can do an intersection of two sets. This is demo, and this is the intersection method. Okay, so I have set 1, set p, set q, and I have intersection set is that, and then I want to print what the intersection is. All right, let's do that. And it gives me 18, 12, and 6. And if we look back here, is 18, 12, and 6. That is the output. Now, let's have a look at the intersection with alternative notation. If I go back here and I comment this out, I can take this line of code, and instead of set p and invoking the member method, we can just go and use the ampersand. Okay, and the result set is going to be the same, 8, 12, and 6. It is identical. The choice is yours, whichever one you want to use. All right, this brings me to the union. Let's talk about union. Okay, here we have union of two sets, A and B, and I have set A, I have set B, and then A union B is basically you take both sets and you combine them. Now if you have a duplicate, you only use one. Here we have 1, 2, 2 and 3, that's why you see only 2 here, not 1, 2, 2, 3. Okay, no duplicates are allowed. Here's an example, 169, 135, 6, 8, and 9. What is X union Y? So 1 and 1, only one of them will be in the result set. 3, we don't have 3 here. 3 is definitely going to make it into the result set. 5, yes. 6, only 1, not 2 6s. 8, definitely. 9, only 1 9. Here's the result. X union Y is 1, 3, 5, 6, 8, and 9. In Python, this is the syntax for union. Looks familiar, right? Here we have set 1, then invoking the member method union, in this case union, right? And then we pass set 2. We have set 1, set 2, we pass set 2 to set 1. Alternative syntax is the pipe symbol. Set 1, pipe symbol, set 2. And both techniques work by returning a new result set that will contain elements of both sets without duplicates. Here's an example of, we have exactly that same example that we used a moment ago. I am gonna, let me just demo this out, comment this out, and let's use, this is demo, the union method. Okay, let's paste it. Set 1, set 2, union of X and Y to match what you have here in the presentation, X and Y. Let's see what that yields. If I display contents of X, display contents of Y, and then X union Y is this. Notice there's no duplicates. That is what we get. Now to use alternative notation, all you have to do is do something like this. We're going to use the pipe symbol, and the pipe symbol is found above your return key on your keyboard. It's just this symbol, line, and that's it. And it's going to give us the same results back. There it is. Okay. All right, moving forward. You have some strings, apples, oranges, bananas, pears, oranges, pears, and grapes in Q. What is P union Q? P union Q is apples, oranges, bananas, pears, and grapes. No duplicates, okay? And then here's Python code for that. Let's have a quick look at that. We can, there we go. I'm gonna demo this. This is still union. Just different data types so that you're comfortable with it. There's two sets, and if I run, it gives me that result set. Okay. Key takeaways is that you have set1, set2, and then when you invoke the member function union, it will give you result set, just like the intersection gave you result set back. Okay, now this brings me to difference. Okay, you have a set difference between two sets. Here we have set P and Q. P has 1, 2, and 3 as its members. Q has 2, 5, 6, and 4 as its members. I want to know what is the difference between these two sets. Now, the difference, set difference between two sets P and Q is another set, another result set that consists of elements that are found in the first one, in P, but not in Q. When you do something like this, when you say P difference Q, you're asking for elements that are found in P but not in Q. If I was to rewrite this as set Q difference set P, then I would be asking for all the elements in set Q that are not present in set P. So it's important how you write this as a statement. Let's have a quick look at that. We're gonna take a look at this example programmatically. Let me comment this out. This is the difference now. This is the difference, and this is demo, the difference method. Okay. Here are the two sets. Here's P, here's Q, and actually I called it. Let me comment this out because the code is on. The rest of the code is about set P and set Q, set underscore Q. Here's the difference, and then I am displaying what the difference is. We run it here, and this is the difference. Okay, right there. Now, change this to alternative. There we go. Here we're gonna say that set P minus, just like in math, minus Q, and you're gonna get the same result back. What's in set P that's not in set Q? The only two are 1 and 3. That's why we're getting that back. Okay, that's that. And then there's alternative notation with the minus sign. Now, if we do it the other way, Q minus P, this is what you get. Let's then demonstrate that real quick. That's Q minus P. You know the difference? Let's comment this out. This is still the difference method. And let's go paste that. 1, 2, 3, 2, 4, 5, 6. And we are now Q minus P. And when you run that, you get what Q minus P is. And it's this. Okay, which elements of Q are not found in P? 4, 5, and 6, because 2 is member of P. And I've got one more demo here to show you them side by side. You can, when you review this code, you can actually see them in one example. There it is. I have 1, 2, and 3, 2, 4, and 5. Here I call it minus Q, and this one needs to be minus, not slash. Let's do minus, and let's do this one minus. Let's correct that, and then run it. Okay, it is that. Here's P minus Q is 1 and 3, Q minus P is 4, 5, and 6, and you've seen the previous examples how we got there. Here I used the long form. I called the difference member function. You can change this to just use the minus sign. It makes no difference. Okay, here's this example. All right, that's the difference. Now we also have a what we call symmetric difference. Okay, you have a set, and you want to find out which elements are not shared by the two sets. Okay, so it's kind of like the opposite of intersection. Okay, these are elements that are in one set but not in both sets. Okay, we have P and Q 1, 2, 3, 4, then we have Q is 3, 4, 5, and 6. And we want to find out what is this symmetric difference. Okay, let's have a quick look at that. That's the code. And this is going to be a new demo. This is symmetric difference. Demo, symmetric difference. And let's paste that. Let's make it a little bigger. You guys can see better. 1, 2, 3, and 4 in P, 3, 4, 5, and 6 in Q. And here's symmetric difference. When I execute that, it tells me that, by the way, this is a shorthand symbol, which is caret. We're looking for elements that are in, one set, but not in the other. Okay, that they're not shared. 1 is the one that is there. 2, okay, and then we have 5 and 6. Okay, 3 and 4 would be an intersection, and this is whatever is not intersection. Okay, you want to use shorthand notation. This is the way to do it, and here you can just say set P caret, which is this symbol that's above number 6 on most keyboards. And when you execute that, it gives you this result set. That is what is called symmetric difference. Okay, this brings me now to the code here. You can take a set, then perform a union and do an intersection to see what that is. Then you can look what is the difference between the two sets and what is the symmetric difference. This will give you all of these examples, what we did piece by piece, all in one shot. You can try that on your own. All right, now next thing I want to talk about is what a subset is. Okay, we have A and B. A is 1, 2, and 4. 1, 2, and 4. B is 1, 2, 3, 4, and 5. Every member of A is also a member of B, thereby A is a subset of B. In math, we denote that A is subset of B with this. It looks kind of like a C, letter C that has been pressed down. Okay, that is a subset. Superset is something else. Your set B is a superset of another set. Okay, in this case A. All elements of set A are elements of set B. It's the inverse of subset. B is a superset of A. A is a subset of B. Okay, that's that. All right, and then here's an example how this works. Let's try it. Let's go to here, and this is going to be superset and subset. Okay, I have 1, 2, 3, and 4. Sorry, 1, 2, and 4, and then 1, 2, 3, 4, and 5. We print it, we display what they are, and then we display here that set A is subset of set B, and there's a function is subset. This is a method is subset, and you pass set B to it to tell you whether is a subset. And is superset tells you it's pretty straightforward. It will show you which set is a subset, which set is a superset of another set. Okay, all right, that's pretty much it for introduction to tuples and sets. When we learn conditional statements and repetitive statements or looping, then we're gonna look into lists, sets, and tuples in a little more detail. Thank you for watching, and I will see you in class. Thank you. Have a good day. Bye-bye.